So again, thank you so much for coming to today's presentation. My name is Dr. Tobias Sando with the University of North Florida in Jacksonville, Florida. I am part of the AfroSAFE Academy, and AfroSAFE Academy is an academy it's an online academy that is sponsored by the European Union. And it consists of 3 countries, Tanzania, Ghana, and Zambia. So we conduct research and we help develop resources that will help academicians and practitioners bridge the gap so that we can have that knowledge that is needed to advance the education on highway safety. Today, we have a continuation of our series. One of the activities that we do is we do a series of webinars, and we are glad that today we have Dr. Valerian Kwigizile, who is from Western Michigan University, who will be presenting a topic on safety that he's doing. He's originally from Tanzania, and he is in Kalamazoo, Michigan, where he teaches and conducts research in transportation engineering. He's going to spend the next 30 minutes or so to present on his topic, and then we're going to allow enough time for Q&A, discussion, and input for our future events. So without any further ado, please welcome Dr. Valerian Kwigizile for today's webinar. Thanks. So now I'm going to stop the sharing.
Okay, right, Tobias, I think I can share my slides. Let me see where they are. Give me a moment. Can you guys see my slides?
Yes, but it's not presentation mode. Yeah, now, perfect.
Okay, so I'm gonna move this to the other side. Okay, thank you, Dr. Tobias Sando, for an introduction. So again, my name is Valerian Kwigizile. I am a professor of civil and construction engineering at Western Michigan University. We are located on southwest part of the state of Michigan in a small city called Kalamazoo. I have been here for 13 years now. Before coming here, I was assistant professor at West Virginia Institute of Technology. I'm originally from Tanzania, and my research focuses on traffic safety. I do highway design, I do transportation planning. I have done research in traffic enforcement and different kinds of research that aim at improving safety of road users. So in this topic, or in this presentation, I'm going to share one of my research that I conducted. It has been a few years, actually. It has been like 3-4 years since I conducted this study. But it's focusing on how crowdsourced data can be used to enhance estimation of non-motorized traffic volume. So when I did this study, we looked at both pedestrian and bicycle volume, but the focus was more on bicycle volume. So today I'm going to just focus on bicycle volume. I didn't prepare anything on pedestrian volume. So my presentation is starting with introduction, and then I'm going to go into the description of that case study. I will tell you the data. I will give you information about a survey we conducted and some of the results, and I will conclude. And at the end, if we still have time, I will show you a tool that we developed that can be used to estimate bicycle volume. So just to kind of set up the stage, why is non-motorized traffic volume data critical? I think this is kind of an obvious question. Probably many of you know, we need those information to do safety analysis. We got to know the exposure, we got to know how many people are using a particular crosswalk, how many people, how many cyclists are on a particular street, how many cyclists are on a particular trail, so that we can do safety analysis and ultimately do safety improvements. Of course, if you want to plan an infrastructure, you got to know where and what kind of infrastructure is needed, and you got to know the demand. You're building an infrastructure for how many people? If you want to promote active transportation in your community, obviously, you got to have the first two bullets together, which is infrastructure planned well and making sure that it is a safe infrastructure. But to do that, you got to know what's the demand of your infrastructure. And then economic justification of projects. So those are some of the needs or the uses of non-motorized data. Unfortunately, it's difficult to have non-motorized traffic data. If you compare that with motorized traffic volume, this is hard. There are different methods that have been used to do data collection, trying to figure out how many bicyclists, how many pedestrians are on a street or a crosswalk, counting manually, using permanent and temporary counters, using camera-based monitoring of those locations. Some jurisdictions or some agencies use intercept survey and self-reporting. For bicycle, we use sometimes pneumatic tubes or pressure sensors. So in my case study, I will actually talk about some of these methods, because these methods give you ground truth data. If you do a manual count, then that means you are counting everybody. If you are doing camera-based monitoring, that means you are counting everybody who is on a street. So in our case study, we used some of these methods to come up with ground truth data. But there are challenges associated with traditional methods. Of course, the data collection cost is very high, and coverage limitation. I mean, how many sites you can do manual data collection if you want to count the number of cyclists using your bicycle network? I mean, very limited. And there are seasonal and temporal variability that cannot be captured well with those traditional methods. So there are new methods which actually use technology and try to embed that in the process of counting pedestrians and counting bicyclists. So GPS and mobile app data platforms. This is probably a popular one because we have a lot of apps that people use. These are fitness tracking apps, and those track where those people go, track the routes they use. If that information can be extracted, it can be utilized in combination with other data to estimate the exposure, to estimate the volume of cyclists and pedestrians. Other technology-based methods include Bluetooth and Wi-Fi sensors, computer vision and machine learning on camera feeds, smartphone sensors and accelerometers, integration with Internet of Things infrastructure. I mean, there are some advancement in technology that we can use. In this presentation, I'm going to focus on the first one because that's the one we tried to integrate with manual methods to see how we can improve estimation of bicycle volume. So some of the examples of the crowdsourced data platforms, and I'm sure most of you are familiar with these because they are very popular. Strava, Map My Ride, Cyclophily, Komoot, Night Run Club, Oricycle, Google Fit, Bikeable Route, and more. By the way, the Bikeable Route, the one at the second from the bottom, that was developed here at Western Michigan as part of the USDOT research. And we developed an app which can be used by cyclists to report the environment or the condition of the infrastructure so that we can help planners and transportation agencies to make improvements. So we have that app that we developed here in Michigan. So there are challenges associated with crowdsourced data. One is the data quality and the representation. There is biasness. I mean, we have to acknowledge that. I mean, if you are using, say, Strava data, obviously not everyone is using that technology. So you're going to miss those who are not using it. So you're going to have issues with quality of the data, and you're going to have issues with representation of the population. Privacy and ethical concerns. When we were using Strava data, one of the limitations we faced was sometimes, I mean, you may not get information about who is using Strava, and you may not get good information about when you want to track them, because, I mean, there are ethical and privacy concerns. Technical complexity and cost. It's a little bit costly. It's going down, the cost is going down, but when we did this study, it was a little bit costly. In fact, we couldn't afford doing too many cities. We did 2 cities. Data integration challenges is not that straightforward, and environmental and operational limitations. So there are some of the challenges that you face when you are looking at crowdsourced data. So let me go into the case study then. This was focusing on leveraging crowdsourced data to improve estimation of cycling activities. This study was funded by the US Department of Transportation. It was an 18-month study, and we did it here in Michigan. And the goal was basically we wanted to explore opportunities and limitations that are associated with integration of crowdsourced cycling data with other methods that we use. So the way we organized our case study, we started with extensive literature review, where we looked at the state-of-the-art methodologies, looked at those traditional methods, looked at the opportunities and the limitations of using cycling activities from crowdsourced data that other research have documented. And then we went down and selected sites, we selected cities, and then we selected road segments where we did ground truth data collection. And then we did field data collection. We collected video data to come up with the count of cyclists who are using those segments. And we did a survey of cyclists, try to get gain insight on whether they use fitness tracking apps. And we wanted to make sure that we can look at their characteristics and incorporate that in our process of integration. And then we looked at other sources of data like Strava data. So we used the Strava data. So that was the crowdsourced data. We didn't use data from other apps. Again, as I said, it's costly. We could only afford the Strava data. And at that time, actually, Strava data was probably the most popular one. I know right now we have more, but at that time, Strava data was the most popular one. And then we had other data like weather information. We had information about the infrastructure. We had information about demographics from the census data. We had information about the land use, and all that information was taken into our analysis, descriptive analysis, as well as estimation of bicycle exposure. So I'm going to kind of go into some of those steps in a summary way. So the location of our case study, for those who are familiar with the United States, this is the state of Michigan. Sometimes when we are trying to describe the state of Michigan to someone, we just use our hand. You do this, I think you can see like that's the state of Michigan. Then you can tell someone where you are from. So as you see here, we had our two cities. One is Grand Rapids and another city was Ann Arbor. Ann Arbor is close to Detroit. Detroit is the biggest city in Michigan, and Ann Arbor is a location where the University of Michigan is located. We are located in Kalamazoo, but Kalamazoo is very small, so we tried to use bigger cities, Grand Rapids and Ann Arbor. So we did it after selecting the cities, then we went on to select the sites, selecting streets where we did ground truth data collection. And when we were doing site selection, we considered some factors like land use type. So we tried to mix it up. We got commercial, we got institutional, we got residential, and then we looked at different types of bicycle facilities. So we had bike lanes, we had shared lanes, we had locations where we did not have any bicycle facility, because we still know, even in those places where you don't have a dedicated bicycle facility, you still see bicyclists trying to use it. And then we had, so this was the city of Ann Arbor. We had 10 sites. Then in Grand Rapids, we had 9 sites, again, using the same criteria, using the same factors, land use and facility. And you can see from Grand Rapids, we actually added bicycle trails. We added trails. So we had 3 trails that we considered in our data collection. So we had those 19 sites where we collected the data. So the way we collected data, this is the ground truth data. Again, as I said, we used video cameras to record cyclists. So we installed those on roadways with bike lanes, for example. So that's my student installing the camera, and of course, making sure that the cameras were secured. And these are some of the other locations where we did installation of our cameras. We also installed pneumatic tubes on trails to count the number of cyclists who were crossing those points. So wherever we put the pneumatic tubes, when possible, we also installed a camera so that we could monitor what was going on. But in many cases, just the pneumatic tubes were just the pneumatic tubes without the camera. So this is another picture of the location where we put the pneumatic tubes. And you can see cyclists who are running through those pneumatic tubes, and we are counting them. So all this effort was to make sure we have ground truth data. We know exactly how many people are cycling on a specific site, so that later on when we look at the Strava data, we know what is the ground truth data, and then we can compare the two, and then we can find a way of integrating the two and create methods that can be applied in other areas to estimate the actual volume. So after collecting those videos, it was an intensive data collection process. We had 1,500 hours of video data, and then we processed those video data. We had a software, CountPro software, which we used to do the counting of bicyclists from the videos that we collected. So by using that software, actually, we reduced the processing time by 80%, rather than just using the manual process of looking at the video and counting manually. By using that software, we sped up the process by 80%. So the data we collected were, in total, we had 13,000 cyclists recorded over those 1,500 hours of field data. So those were ground truth data. Like, these are the data we know for sure. These are the cyclists who were on the road at that time. And then we had another set of data, which is the data from Strava Metro. So we analyzed Strava Metro data to figure out the cyclist activities. So essentially count the number of cyclists from Strava data. And then again, as I said at the beginning, we had weather data. We wanted to make sure that that is incorporated in our analysis. And then we had bicycle facility data. We had census data at block level. We had land use data. And of course, we did a survey of cyclists. So Strava data, again, as I said, at that time, and I think even now, Strava is still popular. And we purchased data from those two cities, Ann Arbor and Grand Rapids, and we purchased 1 year of data. So that 1 year of data was the same year when we did our study. And then, so that actually we could match the dates when we did our field data collection and the Strava data, and have a comparison of apple to apple. So Strava Metro data offer activities by nodes, intersections and edges or segments. And you can get information about trip types, whether it is a commute or a non-commute. And they provide you with demographic information, but that is aggregated. Again, that's because of privacy issues, as I stated at the beginning. So we processed the Strava data for the sites where we collected ground truth data for the days when we collected the data. And we found that there were 885 cyclists recorded at those sites during our ground truth data collection. That's approximately 70% of the actual cyclists who we observed at the sites. In other words, that's the penetration rate of Strava data when we were doing our field study. But if you have to look at overview of data coverage of Strava, so this is like showing the hotspot map of Strava data throughout the state of Michigan. Again, you can see that those two cities where we collected our data, you probably see more Strava users compared to other locations. So what is this telling you is that penetration rate of 7% we saw, it may not be the same throughout the state. It might be different from one location to another location. And we actually tried to conduct, when we did the survey, we tried to compare where more people use Strava versus where they don't. So we did the survey, again, as I said. So this survey was conducted at the same time when we were doing our video data collection. And the goal was to learn demographics and cycling behavior of the cyclists. We also wanted to get the characteristics of the trips made by cyclists. And most importantly, we wanted to figure out the proportion of cyclists who are using fitness and health tracking apps so that we can compare that with what we observed from Strava data and utilize that information as we proceed with our estimation process. So the results of the survey showed that we had 16% of people using Strava app and 18% of people that we surveyed using other fitness tracking apps. So that's a total of 34%. And then the people we surveyed, these were 321. So you can see like there is a mismatch between what the data was saying is the penetration rate versus what the survey was saying. But again, I mean, that can happen. And we did not rely on just one observation. We relied on a combination of things. So in terms of the demographics and the cycling experience, on the left side here, you see the age, and on the right side, you see the gender. What we saw was that there is a high percentage of Strava users between age 24 and 44 years. And then people with age of 55 and above were heavily using other fitness tracking apps, not the Strava. And then in terms of the gender, we saw that the proportion of male cyclists using Strava app was slightly higher than female. We also asked them about the trip purpose, and we saw that cyclists were more likely to use fitness tracking app when making recreational trips. As you can see, the orange and the yellow bars are higher on recreational. The gray one is those who were not using any fitness tracking app. And then in terms of cyclists on recreational trips were also more likely to be found on trails. So people who are doing on recreational trips are on trails. I think that makes sense. Then we processed the Strava data. We had looked at those data and we processed them at the street level so that we could match them with the data that we collected manually. So this chart is showing the Strava data we observed per day, per hour, and the manual counts we did. So the blue one is actually showing the ground truth data, and the orange is showing Strava data. You can see like those Strava data and the manual counts are kind of tracking each other. There is a good correlation. It's not all the time, but at some time it's a good correlation. And then we looked at the penetration rates. Again, when we were looking at the penetration rate, we tried to look at by hour, we looked at by bicycle facilities, we look at by land use type. And then what we found was that there is a maximum number of Strava penetration rate between 3 p.m. and 8 p.m. There are few Strava users along roadways with no dedicated bicycle facility. There is a significant portion of Strava users who are using bike lanes and and trails, and on recreational trips as we saw before. We also collected weather data. Again, as I said, we took that data from weather stations in these cities. And then we tried to match the weather data and the bicycle counts. So the line graphs are showing the bicycle counts. Our ground truth data is the red one. The Strava data is the green one. And then the bar charts are showing the relative humidity. And you can see what was happening, like cyclists tend to avoid riding in high relative humidity, which I think is common sense. And then we did data modeling. We looked at different variables. Of course, we had the ground truth data, we had the Strava data, and then we had information about the relative humidity, and we looked at the percent of males in the population that was coming from the census data. We had the percentage of white, so we tried to look at the race, and then we had the percentage of bikers in those census blocks. So we tried to utilize that information in our modeling. And we had bicycle facility information. Of course, we had the bike lane, we had the shared lane, we had the trail, and we had location where there was no any bicycle facility. And then we looked at the hourly distribution, and then we looked at land use type. We had commercial, institutional, we had recreational, and residential. We did correlation of those variables. And of course, what we found was there is a good correlation between Strava count and the ground truth data counts. I think I already showed a chart which was showing the two graphs tracking one another nicely. Now, for modeling, we applied different methods. One was probabilistic model or a statistical model. We used the negative binomial regression, and then we applied machine learning technique. So what we did for machine learning, we had different kinds of techniques. We had the random forest, we had the k-nearest neighbor, bugged regression tree, artificial neural network, support vector machines. And then we took our data, divided it into two groups. We had the training data, the 70%, and then the 30% was used to validate or testing our models. And then, of course, we looked at the performance of different methods. So again, as I said, a portion of data was using as training data, and then another portion was used to check the prediction capability of our methods. So here are the results of the negative binomial model. Essentially, this was estimating the number of cyclists at a given segment, given different variables that you see on the first column. And what we observed was that a unit increase in our Strava cyclist count is associated with an increase in the hourly cyclist, the total, by 9%. Now you can see that that's getting closer to that penetration rate that we had. And then a unit increase in relative humidity reduces the expected number of cyclists on a given segment by 1.1% and 1.4% for recreational trips. Then the other thing we saw from the negative binomial is that trails attract the highest number of cyclists compared to other types of facilities, which I think also makes sense. And a unit increase in the percent of workers who were using bicycle to commute to work increased our cyclist count by 21.1%. So that is coming from the census block. If you look at the census block and you got a higher percent of people who are commuting with a bicycle, then that's going to increase the number of count by 21% on a segment that you're looking at. Then the other thing we did was now we wanted to look at the impact of Strava count on model performance. Like when you incorporate the Strava count in your model, does it improve the performance of the model? So we looked at all the models we estimated, the negative binomial and all the machine learning model. Now, as you can see on these box plots, the addition of Strava count increased the model performance consistently across all the training models, across all the models that we estimated. Essentially, it is suggesting that when you use Strava data as one of the variable in your model of estimating the count, you're going to improve the performance of that model. So when we compared now the performance of the different models, what we saw was that, and basically that this comparison was based on the root mean square error, and we found that the random forest was the best. It was able to explain about 71% of variation in hourly cyclist count at given segments. So as I said at the beginning, when we looked at the Strava penetration rate, we saw that it was 70%. Now, the question is it going to remain the same? No. We know it's going to change. Now, we wanted to see, what if the penetration rate of Strava changes? Maybe you got a penetration rate of 20%. Maybe you got a penetration rate of 50%. What's going to happen in terms of your prediction capability of your model? So what we decided to do was, we know we got a 70% penetration rate as the base, based on our data. Now we tried to kind of prorate that, kind of increase that rate proportionally at each hour, and then increase it until you are at 100%, and then utilize that penetration rate. So basically increase the Strava data proportionally, and then see what is going to happen. So incrementing the Strava penetration rates while maintaining observed counts distribution across all the sites is what we did. Now, when we started now incorporating Strava data in our model with different penetration rates, and then look at the prediction capability, we saw that as the penetration rate increased, so was the capability of predicting, the accuracy of predicting. And of course, as you can see here, if you are having 100% penetration rate of Strava data, that means you can actually explain 100% of variability in cyclist volume in your data. So in conclusion, the cycling activities data from fitness tracking apps can improve estimation of bicycle volume. Of course, if every rider use a tracking app, then if you can get that information, that means you have 100% of the people who are using your segment. In lack of other factors to predict cycling counts, crowdsourced data can be used for prediction. And when I started the presentation, I highlighted the challenges. There are those challenges that we need to think about. So estimates from crowdsourced data are biased towards cyclists who use the app. And different groups of people may prefer different fitness apps. In our case study, we looked at Strava data, but I think it would be helpful if someone is looking at different sources of data. People use different apps, and we found male cyclists and female cyclists are different in terms of how they use the fitness apps. Same was with the age groups. And the other thing we found was there is a difference between proportion of fitness app users in different bicycle facilities. So that's another factor that might need to be considered. So we developed a tool, and this tool is probably, I would say, it's applicable to those cities where we collected the data. I wouldn't say that it can be used in other locations without being adjusted, but at least for those cities where we collected the data, we provided them with a tool where they can actually provide information about the Strava data. So what we did was the city would actually purchase the Strava data, and as long as they can quantify how many people are using Strava data, and then they just use other information, other site characteristics, and then put that information in the tool, and then they can actually predict what's going to be the total volume of cyclists. So for the sake of time, probably I'm going to skip demonstration of the app unless you guys want me to do that. But you got that link. I'm going to share my slides. If you click on that link, you can see the app. We provided a template which has data that you can use. You can see how someone would actually take that spreadsheet and just put in their data and utilize it the way they want to do it. There are reports and papers associated with this study. The first one is the actual report. It's online, you can find it. The bottom two are the journal publications which came from this study. So again, you can find those online. I would like to thank the U.S. Department of Transportation and the Transportation Research Center for Livable Communities, which is here at Western Michigan University. And again, I would like to thank Strava. They provided the data. And also, we had a lot of support from cities when we were collecting data. So City of Grand Rapids and City of Ann Arbor, they helped us a lot. So, thank you so much.
Well, thank you so much, Dr. Kwigizile, for your very insightful presentation. We have about 18 minutes and we would like to go into the Q&A session. So any questions from participants? I'll probably start with a question. I understand that the challenge that we might be having sometimes is when we use crowdsourced data, we collect data from different neighborhoods, and some of the neighborhoods that are using bicycles, maybe those impoverished, poor neighborhoods, and they may not be aware of these tools, or they may not be using these tools as much. Did that show up in your study as well?
Actually, that's a very good point, Tobias. I think that would be in this study. We did not compare the level of income for different neighborhoods. We focused on the differences between facilities, but I think that could be something that could be an important variable to be added, because yeah, you are right. The usability, as I said, the usability of fitness tracking app varies a lot, and it could vary by again the level of income. I mean, if you have impoverished neighborhoods, you may have very few people using the fitness app. So yes, that variable might be important to be considered.
Well, thank you so much. I see a hand. I think that's Francis Filbert,
Yeah.
or maybe it's Alex.
Yeah, we're sitting together here in the same room. Yeah, my question is, Valerian, can you please reflect like how transferable this approach is to the African context? Because the app is international, you can download it everywhere, but the question rather is how many people are actually using this type of tracking their daily motions?
Well, the question of transferability, I think I kind of mentioned something when I talked about the app. I said, for example, the way I see the app we developed is probably applicable to the cities where we used it. If someone wants to use it somewhere else, then they will have to do a lot of adjustments. Now, your question is specifically on African context. I think, I don't know how many people are using these types of apps when they ride cyclists or when they walk across the streets in African continent. So that would be question number one. Someone would have to try to understand what's the penetration rate of these technologies? Are people using it? If they are using it, then that helps in the process of transferability of this kind of analysis that we are doing. Because again, as you saw, we did different penetration rates, which means if someone knows the penetration rate, and if they can get that information of people who are using those fitness tracking app, it can be a good starting point. But still, there are other challenges. One gonna be if you were to look at for example, the context of the cyclists and road users in these cities where we collected the data, and the context of African non-motorized traffic, it's probably still not quite the same. So I would say transferability is not direct. Someone would need probably to use the same approaches we used, but develop specific model for Africa. Not expect like you're gonna take a model that's developed in Michigan or developed somewhere in Europe and just do minor adjustments and apply it in Africa. There are some things that are quite different.
Well, thanks. Now I can tell you that I'm working on a project right now that we are trying to develop data for the Federal Highway Administration. They call it a safety assessment tool for vulnerable road users, and that tool needs us to have ADT for bicyclists and for pedestrians. And even in United States cities, we don't have that data. So we can easily get data for vehicular traffic, but we don't have a repository, a good repository, or a complete database where we can get this data for vulnerable road users, even in the United States. Now, going back to Africa, actually, if you go to Africa, here in the United States, we are trying to promote and incentivize people to walk or use bicycles. But in Africa, people are using it. We don't even have to incentivize. We just have to make our infrastructure much better so that we can have more people can accept that that's their mode of choice, not just a mode because they can't afford, using private vehicles. So my question to you guys, probably not only for Dr. Kwigizile, is, are there things that you have seen maybe in the African context that could help so that we can quantify the amount of people who are using our roadways as vulnerable road users, bicyclists, pedestrians, bearing in mind that anytime when we're doing these safety studies, we need to have some exposure variables. And that exposure variable, I feel like it's missing a lot of times. Now, if you go to Africa, let's say Tanzania, for example, some streets have more pedestrians than you can think of. But nobody is counting them. We don't know how many. Maybe folks in Tanzania, I don't know. Mr. Bigambo, do you know if there's data somewhere, or maybe there's a project that has been done that counts pedestrians and bicyclists that we can use in safety studies?
Yes, we don't have a systematic study, though in a bus planning, like BRT, they have included pedestrian NMT studies, so, but it's on a small scale. So we don't have a systematic study as well. We are coming from the pavement design aspects, where we take these 24 or 7-day counts, and then we factor those for using the empirical formulas. Most of them also developed from developed countries. So what I can conclude that we don't have a specific and a systematic study yet.
Well, yeah, thank you so much for that information. I think it's time. I don't know, maybe the University of Dar es Salaam can assign one student to at least do this. I think we can help in terms of knowledge because we have ways of counting pedestrians here in the United States using like camera detection. But in the United States, when you count pedestrians, it's only like maybe 20 pedestrians per hour who are crossing streets and so forth. In Africa, you're talking about hundreds of pedestrians, if not thousands, crossing streets. So, whatever we use in the United States will probably need to be, or in developed world, will probably need to be calibrated to be used in Africa. But those are some of the things that I think will be helpful to see if maybe the University of Dar es Salaam can partner with TANROADS and other roadway agencies to see if we can have a way or an approach of having exposure variable in terms of the number of pedestrians or bicyclists on our roadways.
So if I can just add one more thing on that, based on my experience with African cities and non-motorized in Africa, especially the pedestrians, I think it's a very big problem to try to quantify how many people are using a specific street. And part of the reason is it's probably volatile. It changes a lot from one location to another location. And the other big issue is some of these locations or some of the streets that people are using to walk or to ride bicycle are not even like well-planned type of roadway networks. So if you were to do, for example, so why am I bringing up that is because when we try to estimate non-motorized volumes, we could do a study like origin destination type of studies and then try to come up with the estimates of non-motorized users. But the thing is, the origin destination study in some African cities might be even hard because of the network not being well defined. So for areas where the network is well defined, I think what Tobias you are suggesting could be used there. We could actually try to estimate the number of pedestrians and bicyclists using different ways. I mean, using videos. I mean, if someone could conduct an extensive study, observe how many people are using those streets, maybe they could come up with a way of estimating the same at different locations. But again, now it's a very challenging problem, and I agree with you, Tobias, that maybe the University of Dar es Salaam and maybe governments in Africa, they need to kind of put more emphasis on this and kind of put more resources in getting this type of data. It's very, very useful. As I started with my presentation explaining why we need those data, and as Tobias said here, I mean, that information is very important.
Thank you so much. And I think using video detection now, we should be able to collect that data, especially in areas that are heavily pedestrian friendly. Like, we have areas in Tanzania that a lot of pedestrians use, and we have a lot of accidents. So I think this is a metric that we would definitely want to have.
And I think it's the same maybe across Africa. It's not just Tanzania, by the way.
Sure. I see another hand. I think that's Philbert.
Yeah, actually, thank you so much and for nice presentation. I had the same opinion with Tobias because even me, I did in my PhD, what I did, I just find first of all the area which is hazard for motorcyclists. Then I did a count. So as we said that we can concentrate to the area which we think is more maybe vulnerable for more crash or accidents. Then we can try to count. We can approach by that way. We try to identify the area which we think are more maybe prone to the accidents. Then we can have a count from that aspect.
Okay, anyone else? Any other questions? Any other comments?
Yes.
Charles,
there is a comment.
Yes.
Go ahead.
Okay.
Go ahead,
Thank you
Charles.
very much. Very interesting presentation. Thank you. I think on the subject of counting pedestrians, it will be interesting to see how we could collaborate to, especially if we have video data, because this is a very important thing. Why NMT is not probably planned is because, one, the standards are not developed, and there's virtually no data apart from limited count data, roadside data that may be used to justify the provision of sidewalk. There's nothing. But I think with video technology, the data could be collected. I think where the challenge comes is sometimes the analysis of the data that probably we might need some tools to be able to do that. I'm speaking from the point of view of Ghana. So I think that this is something that if there's opportunity we could look at together and see how we can, especially if we can provide some count video data and we can get some analysis. I think because we have a myovision device that can actually be put on roadside to be able to get police data for intersections, and these are places where there's a lot of well-defined movement and can be used to collect exposure data that can be useful for industry and also for research. Thank you.
Thanks. Maybe I can ask Alex. I know Sweden is very big on sustainable transportation, and a lot of people use bicycles. They walk. They use transit. How do you guys collect data for bicyclists and also for pedestrian?
Yeah, well, it's still a lot of manual counts, I would say, and each municipality, they kind of develop their own strategy. So there is no standard. Some are really just 1 week in spring or in autumn. They just send a bunch of students to lots of intersection and count pedestrians. There are also permanent bicycle counting stations, and they are really used not only for collecting the data, but also using for marketing bicycling as a transport. So like they're really well visible, and like you can see today there has been like 300 bicycles who passed, and you have the annual number. This year there were like 20,000 who passed. So they're really made to make cycling visible, to cyclists feel that okay, we are part of a big community. And we at our university, we had a project also looking on how to combine when you have several point measurements where you have like continuously over the year, you have like every hour you have a bicycle count, and then we try to combine with some kind of app update. So Strava is not that big in Sweden actually. So usually we try to recruit people. We have a special app, recruit people, explaining this is for kind of measuring traffic, measuring, recording the what would be the right name, like how people are traveling. So they are enrolled for a week or two where all type of trips they're doing are recorded there. And it's partly automated. It recognizes whether you're walking, cycling, or on the bus, but also they are asked at the end of the day, they're asked to correct. So this is the automated guess, but if it's wrong, can you please correct it? And usually we get like several hundred of people providing that data. We don't pay them. It's just like, would you want to participate? Usually people don't mind to help. But then the challenge comes. You have those permanent counts, and then you have these up data. And of course, people who volunteer, they're biased. Like somehow they're usually like they're bicycling activists, or like they have a reason why they get interested into that. So they're not very representative for the entire population. So the challenge is like how to match those two data sources, how to use like the ground truth from point measurements to how to use them to scale up the data from the up. And our findings was that for bicyclists, it worked relatively well. So like you just find some magic conversion number and it works for the entire network. It was quite okay, but it didn't work that well for pedestrians. So there, something more intelligent is needed.
Well, thank you so much. So we in the US, whenever we have trails, because of the activists, we have those systems that will show you how many pedestrians or how many bicyclists so far since the beginning of the year and so forth. But when it comes to like real intersections where accidents are happening, you know, that we would like to know how many jaywalkers were there, how many people crossed at the the crosswalks. That data is normally missing. I see Lee, I think he was mentioning that in South Africa, they've done some work for I think for school zone or for intersections where we're close to schools. Do you want to give us some more insight on that, or you're not in a position to talk?
Sure. Can you hear me?
We
Yes.
can.
Great. So this was done in the NGO sector. So this is not fully fledged research. It's more of an informal kind of citizen science project. But the Global Alliance of NGOs for Road Safety asked NGOs around the world to analyze pedestrian safety with a particular focus on school children at key intersections. And what I found very interesting is I assisted another NGO to do an analysis at a semi-rural intersection, and I did one at an urban intersection in Johannesburg. And the number of pedestrians, and we counted primitively with clipboards and checklists, the number of pedestrians at the two intersections, which are markedly different in their physical appearance, was virtually identical at around 1,200 in the hour before schools open. So really massive movement of child pedestrians, from young children up to older teenagers. The bicycle counts were slightly different, and I actually can't remember which intersection was higher. But I was keen to join this webinar, just wondering how we could maybe do something a bit more high tech, but in a very low resource environment where cameras are not an option. Few people have ordinary watches, let alone smartwatches, let alone activity trackers of any sort. And I can't really see how we would get more high tech on a big scale in a country like South Africa. One of the deterrents in terms of tech options is crime, that people are very nervous about being victims of crime, having smartwatches snatched. If cameras are mounted, for instance, by local municipalities, they tend to be stolen or vandalized. So, yeah, I'm fascinated by the sort of first world, high income country techniques that have been outlined by the speaker. Thank you very much. And just trying to think how we could use whether we could use some of those on a broader scale in South Africa. And I can't see that it would be easily possible, certainly not at a citizen science kind of level.
Well, thank you so much. Any last comment before we close? I think we are running out of time. Well, again, I'd like to thank Dr. Valerian Kwigizile for his very insightful topic that is well needed in Africa. We realize that we might need to calibrate our approach on collecting data, but we have to find ways of collecting data, whether it's proxies or like crowdsourcing, or whether it's using technology. We realize that the exposure data is missing in safety analysis when it comes to vulnerable road users, especially pedestrians and bicyclists. And hopefully we can take this to action and see how, you know, our institutions, higher learning institutions and our agencies in Africa can collaborate with us to see how we can address this issue. Alex, would you like to close us out with a word?
Well, yes, I will just join you, Tobias, in thanking for this interesting talk. And also, I think it was quite interesting discussion afterwards. And we should kind of admit that there is more research needed. It's a usual conclusion, but yes, if we want to use new methods, new technology in African context, it has to be adjusted. And we have to think about how to do it. Probably like high tech, that's not the way to go. We should look for low-cost solutions, but that's definitely data that is hidden. That we don't realize how big is the amount of pedestrians because there are no numbers. But generally, my impression is that African cities are walking cities. It's not car cities, it's walking cities, but they're not totally not walkable. So there is lots of work still to be done.
Well, thank you so much. And again, I echo the same sentiment that there's a lot of work to be done. This academy is about safety, but others who do traffic simulation, and this is the data that can be used, because without this data, it's hard to find those operational characteristics that you want on a simulation. So it can have a multifaceted use in transportation engineering. And again, thank you so much. And I hope to see you in our next webinar that will be announced soon.
Yes.
Thank you. Thank you, everyone.
Thank you.
Thank you.
Thank you.
Bye.